Our first speaker is David Ibanez. He is from ESA ESTEC and involved in the Galileo, it's a system team there. David, the floor is yours. Thank you very much.
Thank you, Werner, for the introduction. Good afternoon, good evening, everyone. I will share my screen.
David, we can see right now.
It's okay now?
Yeah, it's okay. Thank you.
Okay, thank you. Yes, thank you, Werner. So yes, as Werner said, I'm David Ibanez. I work as the head of the Galileo first generation system engineering unit at ESA ESTEC. So I will present today a bit on the status of the Galileo constellation for the first generation, and also on the developments, the status of the developments for the second generation. First of all, for many of us working in Galileo, it's not unusual to whether when you know someone or from family or friends, they ask you, when will Galileo be working? So I think the answer is it's been working already for a few years. So there are a couple of applications I wanted to show you today. This one is available for the Android phones. It was developed here in ESTEC in the lab. It's called Galileo PVT. So this shows that only with Galileo satellites, here, so it gets the positioning here where I am in ESTEC. There is this sort of virtual reality plots as well, with the position of the Galileo satellites being used at the moment to calculate the positioning. That is just to show another one. And this is a GNSS view available for iOS and Android. This has a nice augmented reality feature showing the positioning of the satellites again. Just showing as a practical example that Galileo is there. So recalling the beginning of the project, so Galileo is an initiative from the European Commission to put Europe at the forefront of the satellite navigation sector. And today, Galileo provides a highly accurate, guaranteed global positioning service under civilian control. So basically, the governance of the Galileo program is the European Commission as program management, ESA as system design authority, and EUSPA as the service and exploitation responsible. So today, it is estimated that the number of devices with Galileo enabled is above 4 billion. If you want to know whether your device is capable to use Galileo, you can go to this website here, usegalileo.eu, and you'll find out that it's already enabled to use Galileo. This is just a quick recollection of the history of Galileo. Basically, the program started in 2005 with the development of the system testbeds and the first satellites called Giove. In 2013, there was the in-orbit validation with 4 satellites launched. And already in 2015, so basically 10 years after starting the development, the initial services were declared. So Open Service, Search and Rescue, PRS. This I will elaborate a bit on those in the next slides. Then after that, we started the exploitation phase. So with the increase in the constellation and the availability of the services. Today, we are about to reach this full operational capability that basically will happen when we have the 24 operational satellites. I will show in a moment the status today. Then, as the first generation is almost reaching FOC, then we are starting also the development of the second generation. As I said, today the Galileo services which are in operation and available to the community are the open service, the PRS service, search and rescue, and then in navigation there is also EGNOS to support aviation applications. So I will talk about a bit more about those in a moment. So today this is the status of the constellation with the Walker constellation, the 3 planes. Today there are 28 satellites flying. This is the status. So 23 are operational and usable for navigation services. And then some of them 2 are unhealthy, 1 unavailable, and 2 spares. The last launch we had was the Launch 11 with 2 satellites that entered into service in 2022, August. And here below, this is important statistics on how Galileo is performing. So this is the signal in space error, root mean square statistics. So basically here you see, starting from the left, that the best satellite in the last quarter of this year, so in the first quarter of this year, was the satellite 0219 with 1.8 centimeters error. The worst satellite is one of the ones that is now declared inactive because it was starting to not performing well. In terms of the full constellation, here in the middle, you have the best day, 0.096 meters, or really accurate in January. The monthly, the best satellite is the GSAT 0215 with 0.19. So very impressive performance. This is thanks to the clocks that we have in the satellites embarked. So there are 4 satellites from Airbus, Germany, which were the original 4 ones in the project, and then we have 24 satellites built by OHB, Germany. All these satellites embarked 2 types of clocks. EHM clocks, more accurate, passive hydrogen maser, and 2 units redundant for RAFs, rubidium atomic frequency standard. Talk a bit about the services. So the so-called open service is the one that is publicly used by everybody to get the positioning on their device. Galileo provides global coverage for positioning and time. There is a Galileo system time reference. It's free access, no charge. It's provided in single and dual frequency in E1 and E5 bands, and is fully interoperable with other GNSSs like GPS. So here on the right-hand side, you see this plot. This shows the typical positioning performance at user average location. I think this is from last month. It's a monthly basis, and as you see, it's 1.67 meters accurate. So it's quite good. In the last 2-3 years, the service has been fully available. You see this 100% availability for accuracy, horizontal accuracy, and timing as well. The next service, which is fully available to users, is a search and rescue, which is not a navigation service, but the satellites embark a search and rescue payload. It's used to relay the beacon signals from a user in distress to activate the emergency rescue services. So on this, also Galileo has contributed to this COSPAS-ASAT community with the Galileo satellites, and this has revamped what was available in medium Earth orbit for this service. Then for the PRS, this is in initial service stages. This is the service that will be used by the member states, governmental users. It's a more secure service to provide positioning time as well with encrypted signals on E1 and E6. Basically, it's designed to provide greater robustness and higher availability, and the access is controlled through the so-called CPA, competent PRS authority, but there is one per member state. This is the documentation for each service. So for people who want to know how it is designed or how to use, or receiver manufacturers, where to find information is in the GSE website from USPA. So you see the OS service definition document published in 2021. Then the SIS ICD for the open service as well. And also on the right-hand side, you see for the new services which are going to be declared, have been declared soon, or will be declared soon. I think my colleague from European Commission will elaborate on those. The high accuracy service definition document published in January, and the corresponding signal in space ICD, and the open service navigation message authentication ICD as well. So this is all available publicly in the GSE website. As I said, so once open service was declared, we started working on addressing the user needs on the satellite navigation field with a number of services provided in the same infrastructure or with little evolutions. So one on the positioning, we have the INAV improvement, which allows for faster time to first fix. The high accuracy service allows sub-decimeter level position accuracy, and OSNMA is a data authentication service. I think these two are the core of the presentation from my colleague from Commission. CAS is also being designed now to provide control access and authentication functions to users. The safety of life will support integrity applications for aviation. Then not in positioning, but on services, but on top of the search and rescue, we will have the emergency warning service to alert population in case of an emergency. These alerts are sometimes we get now by SMS, so they will be also transmitted by Galileo satellites. And the beacon command service, which is for remote control of the search and rescue beacons, and be useful for commercial planes. Zooming in one of these improvements, which is now basically almost available in the full Constellation today, this INAV, the so-called INAV improvements. Basically here is a redesign of components in the signal with this reduced clock and ephemeris data and rich Solomon clock and ephemeris data that allows the user to acquire a position fix from Galileo 2 times faster than without the INAV improvement, and for timing. Basically, this allows the user to compute faster the positioning. Here you see the one in the middle. It's a bit difficult to see, but with the previously to this improvement for INAV, what so-called legacy here in the plot. Basically, the acquisition of the positioning fix was about 30 seconds, 90% of the time. Now with INAV, is this yellow bar, it goes in the order of 10 and 15. So it's really by a factor of 2 that with this improvement, which was just a small patch in the satellites, then the users can benefit from this. Also, once we have all the services implemented, then you start thinking on how to make the Galileo services more robust. So one of the improvements that we have now achieved is this so-called extended operations mode. Basically, the application of this improvement is that if there is a problem in the ground segment, like happened 3 years ago, then the user will still be able to continue using Galileo with a graceful degradation of the performance up to 7 days. So this is basically without the ground computing the refresh of the navigation message. So this service, or this part of the open service, will be published in the next open service definition document updates later this year. So, and this will increase significantly the robustness of the system. Then moving on to the second generation. So why have we decided to, at program level, to embark in this development of the second generation? First of all, is to use a state-of-the-art technology in space and in ground. So at satellite level, it is possible now to use more signals and add configurability in the signals, improve the signal power, and with all this, improve the performance for the user. Then at technology level, we have to think that what is now in operations, basically in terms of satellites or on the ground, is in some cases more than 20 years old when the development started. So with this opportunity of the second generation is a good one to refresh the technology, improve robustness, efficiency, operability. Then the satellites come with this the possibility to use satellite orbit racing capability in dual launches. The satellite lifetime is also improved to 15 years. Minimises the in-orbit maintenance activities for the satellites, housekeeping. Satellites come with inter-satellite links. Again, this will improve the performance of the system without the need to increase the infrastructure on ground. Of ground to space, the time reference on board, and the development is using agile methods. So basically, this will allow all the flexibility that we are trying to use now in the first generation, but it's really coming to the limit in terms of what you can do with the signals and with the satellites. Now with the second generation, these possibilities expand. Status of the procurement is basically for the satellites. There is a dual source with Airbus Germany and Thales Alenia Space Italy. In both contracts, both satellites have passed the preliminary design review, and the first hardware is available for testing. Here in the center, you see that basically the design of the G2 satellites will include 2 operational satellites, hydrogen masers, 2 evolution satellites, and 5 experimental clocks. So there's really, this is why we say the time reference on board is improved, because now there will be nine clocks in each satellite. And then we have also launched the contracts to refresh the technology in the ground segment. The system test beds that will be used to start testing the new capabilities of the satellites. 7 contracts and on the test beds as well. And this is a bit of a repetition, but basically, yes, the design of the satellites will allow move forward on the capabilities of the satellite navigation with this increased capabilities in the signal, improve EIRP, the inter-satellite links, the onboard, the authentication that is now implemented on ground will be possible with the satellites to be done on board as well. The rest of the features I mentioned before. Basically, what we look with this second generation is to reduce the time to market now, with this availability of the signals, more signals in the satellites, and the possibility to reconfigure. We estimate it will allow to deploy new services from 15 years to 1, because you will not need to build new satellites. Moment, this I will show in the next slide. Here, basically, this is the roadmap we use at program level. And you can see that for the different services, these are the services that exist now, and how even after the first launch of G2 satellites, there will be improvements that the user will be able to observe with these new satellites. So this is for the open service part, OS, the Galileo 2 GPS time offset, or UTC, disseminated by Galileo, time service monitoring, positive pilot, safety of life, and the high accuracy service. Again, now we are in HAS phase 1, and the G2 HAS, the capabilities will evolve. Second part of the roadmap is on the OSNMA, the authentication service, CAS, emergency warning, and for SAR. The G2 satellites will also support the search and rescue service. So all this will improve. So just to conclude my presentation, some basic takeaways that I would like to take with you. The Galileo performances are outstanding. It's really like to say that the Galileo is the GNSS is the best in class in terms of performance and accuracy. This improvement for with the INAV is almost fully completed now in the Constellation. The high accuracy service, as Ignacio will present, was declared earlier this year. The navigation message authentication, we are now in testing phase, and is planned for declaration later this year. Parallel to all these operational services, we are starting the second generation development, mainly the satellites and the test beds and the tool. So hopefully in the next IGS we will report the status also on this. My presentation. Thank you very much for your attention.
David, thank you very much for all the very interesting things. I believe that there will be a couple of questions in the question session. And with that, again, thank you very much.